So any questions about the plan? Here is the plan. I will share it with you. The plan looks something like this. We are on section 9.1 today. We're going to do 3 sections of chapter 9, 9, 1, 2, and 3. It's on correlation and regression, and then some confidence intervals and hypothesis testing regarding correlation and regression. Excuse me. And so we're going to wrap that up next week. Then we've got the final exam is going to be on Thursday, May 7th. And I'm going to open up the exam window from 8 until noon. And so you will need to show up online, share your smiling face with me on the Zoom meeting, and then you can get started and work on the test during that time window. If you don't think, now I didn't plan it to be like a 4-hour-long test. I only planned it to be a regular, I planned the test to be about an hour and a half and like a normal test. So it's just regular test size, but sometimes people feel like they need a little extra time. So I've got the window open from 8 to noon. Questions about our calendar or what to expect? Beautiful. If you think of some, you can certainly write me an email as we head down the road. Okay, we're going to talk a little bit about correlation today. This is a change of pace. It's our first opportunity to look at 2 variables at the same time. So if you recall, for the most part throughout this class, we've looked at lots of variables, but only one at a time. So maybe we were considering how tall people were, or how long it would take to recover from a particular illness, how far you drive your car, your grade point average, lots of things. But we only looked at them one at a time. And now we're going to look at 2 variables and ask sort of some natural questions, which would be, is there a relationship between these 2 variables? So we might look at a person's height and their weight and say, is there a relationship, right, between height and weight? We might look at a person's grade point average and their number of hours that they work each week. And we might say, is there a relationship between these 2 things? We might even make a prediction that as a person has to work more than a 40-hour work week, that their grades suffer. Or maybe it's the other way around. We might want to know if there's a relationship. And so we want to look at 2 variables. And to do that, I think I'm just going to jump over to the book and share a few things from the book with you. So here are the class notes that I made for you. It's essentially a big chunk of the textbook. And it's chapter 9. So what we want to see is some chapter 9 stuff. I don't know why that won't go away. That's interesting. Okay, let me just make this a little bit different size. And I was kind of hoping, I was going to just get this sidebar out of there, but it sure doesn't seem to want to go away, does it? Oh, there we go. Okay, so here is the textbook, and here are some notes regarding correlation and regression. Notice that there are 4 sections in this chapter, and we're not going to do multiple regression. Multiple regression is when you have more than 2 variables, and for us, we're just going to get our feet wet here in the beginning of chapter 9, which is 2 variables. So we're going to look at correlation, linear regression, and some measures of regression and prediction intervals. That's what we're going to look at. So the first thing we want to do is consider correlation. We want to understand and explain it. We want to talk about independent and dependent variables. We'd like to find something called the correlation coefficient. We'd like to perform a hypothesis test to see if the correlation coefficient is what we say it is. And then we want to make a distinction between correlation and causation. So correlation, it turns out, is a relationship between 2 variables. Okay, And when we have that, the first thing we generally do is, well, other than listing the data, we would want to maybe make a picture of it. So you can think about being way back at the beginning of this class. And essentially what we're going to do is go through all the chapters again, but this time using 2 variables at a time instead of just 1. So the first thing we wanted to do is make a data display, right? We wanted to make a picture of the data and see what's happening. Then we might want to find the mean and the median and the mode, the standard deviation of each of these variables. Then we want to look at whether or not there's a relationship between the 2. So that is our plan. So the first thing we want to do is make a scatter plot. So I need some data. So here are some scatter plots that are already made. Notice that you graph the x's on the x-axis and the y's on the y-axis. And then we look at the scatter plot and we try to make a decision on whether or not there's a correlation, whether or not there's a relationship. And so one of the things that might happen is that as x goes up, y goes up, right? The more you study, the better your scores are. And we would say there's a positive correlation and that it looks linear, right? It's going up kind of like a line. That's one thing that might happen. Another thing that might happen is as you practice more, your golf scores go down. And so we would say that's a negative correlation, and maybe it's linear, right? So that if you practice twice as much, your scores go down twice as much. Another thing that could happen is, of course, there might be no relation at all. It's just kind of random. You work a 40-hour work week, your scores are this. You work a 25-hour work week, your scores are this. Right? They're just kind of random all over the place. And there doesn't seem to be a relationship at all between maybe the amount of hours that you work at your job and your scores on your tests. Correlation, though, can also come in, there can also be a relationship, but that relationship may turn out to not be linear. In this case, it kind of looks like maybe it's parabolic. It goes up for a while, and then it goes down for a while. And so we could have a correlation or relationship, and that relationship may not end up being a linear relationship. We're going to start out looking mostly at linear relationships, and then we might look at some other shapes. Right? We might end up with a parabolic relationship or something else. Now, to make one of these graphs, these scatter plots, we're going to need some data. So here is some data. Right? And this data is from an economist that wants to determine whether or not there's a relationship between a country's gross domestic product, GDP, and carbon dioxide emissions. Essentially, they're saying the more money we have, the more we pollute the environment. Right? That's what they're wondering. So they go out and take a sample of a bunch of countries. It would seem that the World Bank or the US Energy Information Administration has some data on this. We would look at GDP in trillions of dollars, and then we would look at CO2 emissions in metric tons. Begs the question a little bit, where do we get this data, and how do we know that, how do we know that a country with $1.8 trillion in GDP is producing this much carbon dioxide emission? I'm not even sure how they measure carbon dioxide emissions. So that might be worth looking into, right? But for us as statisticians, we're going to trust that this data came from somewhere and that it's sort of reliable data. But given the data, we want to do our analysis. So just like way back at the beginning, when we were talking about ways of collecting data through experiments or surveys or observational studies, we're not going to be too concerned in this class about where the data came from. And certainly you, as an experimenter yourself, would have to be concerned about that. We're going to start our journey, I guess, with the data at the point where we already have all this data, okay? So, and then we're going to analyze the data and see if we can draw some conclusions. So just like we did way back in chapter 1 and 2. All right, so our first job is to make a picture. So we have some X's and we have some Y's. In statistics, we give these, we give the X's and Y's kind of special names, okay? We talk about the Y, the X, sorry, let's do the X first, as being the independent variable. In algebra class, we probably talked about independent and dependent variables as well. But in statistics, we sometimes call the X the explanatory variable and Y the response. Okay, this is implying that there is a relationship between the two. In other words, for a given X, we get a different response, right, from the Y. Okay, so if you hear those words or read about them as you're reading through the book, that's where they come from. So here's what we want to do. We want to take this data and we want to make a scatter plot. Now for me, I'm thinking that I want to use Desmos. So let me actually stop sharing this and see if I can share my whole, computer with you. Share everything. That way I can put the data over here. And then maybe right here, I don't know, how's that looking? Can you guys see all that? Maybe right over in here, I will put, I'll put us over there. Oops, that didn't work. I will put us over here. Okay, and then right here, we'll go to Desmos. So for me, I really like to graph in Desmos, and Desmos does a really nice job with two variables of data at a time. So it has a nice X and Y axis and a place where you can put in your points. You can certainly do this by hand with a piece of graph paper, but I'm thinking nowadays people pretty much don't. So go to your favorite device. Now, you can also do this on a TI-84. If that's a little bit more convenient, you're going to put the X's in list 1 and the Y's in list 2. And for us, we need a table. So we're going to go under this plus sign right here, and we're going to say add a table. Now, by default, it calls it X sub 1 and Y sub 1. If you want to rename that GDP and CO2, you certainly can. I usually just leave it the default. And then our first task is to put this data in. So just like back at the beginning, this is sort of an important task. Can you type these in correctly? Because once you type them in correctly, of course, the computer's not going to mess them up again, right? So it's kind of a big deal of getting them in correctly at the start. So if you're following along, see how well you can type, okay? I tend to do the X's first and then the Y's. That works. If the data happened to be selectable, look, I can't select it. Over here, it's in a PDF, right? I can't grab it. If you can grab and copy the data, then you can copy the data and paste it in. That's sometimes a little bit faster. This is also going to work in Excel and StatCrunch and other tools as well. But I really like using Desmos for making graphs. So I'm going to use Desmos. Okay, 742.3. You guys are not on this morning, so I'm just talking to the screen by myself. You're certainly welcome to have an actual conversation by turning on your mic or your video. That would be fine. Certainly, if you have a question, you might want to chime in. And if you, if I make an error, which is possible, the quicker you let me know, maybe it'd be easier for me to catch it. Anyway, there's the data. Okay, we put it in. It looks okay to me. We got the same number of X's and Y's. That's a good way to check. We got 1, 2, 3, 4, 5, 6, 7, 8.
How did you get that on Desmos? I don't.
This table, I push this plus. This little plus right here says add.
Okay.
Okay. And then you can start putting it in. All right, so now what we want to do is get these points plotted on here. Well, it already says they're turned on. right? Because I can see them. They're blue and they're turned on, and I don't see them on here. And that's because I'm looking at minus 10 to 10 and minus 10 to 10. So you're going to have to, adjust, zoom this window to a new viewing window. And in Desmos, the easiest way to do that is push the graph settings and then come down here to the x-axis. So if you were doing this on paper, right, you would have to look at the x values and say, what scale do I want for the axis? And that's very similar in Desmos, except in Desmos, you can just kind of scroll in and out. But even scrolling in and out, I don't see the points. And so I'd go over here to the graph and I'd say, well, where are my x's? My x's look like they're between 0 and about 5. Okay, so I'd say maybe 0 to 5. It doesn't look like 0. How about 0 to 5? And then where are my y values, right? And so in this case, it looks like my y values are somewhere between, I don't know, 200 and 1200 maybe. So I'd say maybe 200 to 1200. And then pop, there it is. There's all our values. Then if I scroll out a little bit, everything seems to be scaled pretty well. So that's a scatter plot. If you were making it by hand, of course, you'd make a scale for the x, you'd make a scale for the y. Here, Desmos has chosen to go by ones on the x. And of course, what is that in? 1 trillion, right? Trillions in the x. And it's going by 200s in the y direction, right? In terms of million metric tons. Then to plot the points, you do just like you did in your very first math class. You go over the x value, you go up the y value, put a dot, go over the x, up the y, put a dot. And of course, Desmos does that really quickly for you, and everything's nice and neat, and I kind of like that. Questions about making a scatter plot? Yeah, it seems kind of easy. I think you guys have probably done that before. Okay.
So,
Okay, good. The hard part, I think, about making the scatter plot, especially using a tool now, is actually just typing in the data correctly. Okay, so you got to copy it out of the book or wherever it comes from and get it into whatever tool it is that you're using. After that, Desmos pretty much does all the heavy lifting for you. Now, the next thing that we're going to do is look at this data, and we're going to say, does there appear to be a relationship between x and y? And the two that we're most concerned about is, as x goes up, does y go up? As x goes up, does y go down? And does it appear to be following a line or maybe some other shape? And so that's for you to decide, right? You look at it, you say, well, it kind of looks like as x goes up, the y's go up. But it doesn't look like these points are really tight to a line, right? They seem to be sort of following, but not so much. And so you'll have to get a little practice with this, but what most statisticians would say is that there appears to be a, maybe not a strong linear relationship, but maybe a medium or a weak linear relationship. And so the next job is to, excuse me, fit a line through this data. If this looks like a line, then what line? Okay, and so what we might do is find the average. So we would say, find the mean. So here's how you find the mean in Desmos. You say x sub m, maybe let's call it something, is the mean of the x's. So we get the average x is 2.29, and the average y, I'm going to call it y sub m just for so I can refer to it later, is the mean of the y values. So the mean of the x's is 2.29, and the mean of the y's is 512.97. So what does that say? And that's saying that the average GDP of the 10 countries that we looked at is about 2.29 trillion. And the average Y value, or in other words, the average CO2 emission, is about 513 million metric tons. Notice that now we have two lists, or two variables. So we can ask all of the questions that we did back in chapter 3 about statistical measures for each of these variables. We can find the mean of the x's, we can find the median of the x's, we can find the mode of the x's, and of course we could just keep doing that here in Desmos. There's the median, right? How do you find the mode? You would find the one that happens most often. So this might actually be faster. The Desmos doesn't have a command for the mode, right? So what would you say? Well, none of them occur more than once, so you'd say there's no mode. You can also find the standard deviation. Now, I don't remember how to type it in Desmos, so maybe I'll use the keyboard down here, go over to functions, go to statistics, and then here's a whole list in case you don't know how it types it. In Desmos, right, we would type standard deviation as standard deviation. So the standard deviation of the x's is 1.2. There's also a function down here that's kind of cool. It's called stats. And if we find the stats of the x1, let me close this up. Let me get rid of these so there's a little room. Then it just finds all of our 5-number summaries. So the first quartile, the median, the third quartile, the max. And this should be pretty familiar. We did all this back in chapter 3. And so I guess in a way, we do have a cumulative final. We still have to be able to find the mean, median, mode, standard deviation, statistical measures of a list of data as we sort of wrap things up in chapter 9 here. And so here's chapter 3 again. Now the good news is, good news, bad news, I suppose for you, is that I'm not going to have a cumulative test. I'm not going to ask you questions directly from chapter 3. But for sure, if we're going to do 2 variable statistics now, you ought to be able to find all those statistics for the variables that we're looking at. Okay, and we're interested in the mean. So what's the average? And so where is this average, right? Let's put our average point on here. So to plot a point in Desmos, you would say the x value, and then you'd say comma, the y value. And so that plots a point. There is the average. I'm going to make the average red. Let's make it red so we can see it right there in the middle. So there's the average value. Okay, that means that there are some x's smaller and some x's bigger. There's some y's smaller, and of course there are some y's bigger. This is the average of the x's and the y's. And so one of the things that we might look at is where is the average going through? So I'm going to graph y equals the average, and I'm going to get a line right through here, which I think I'll also make red. Oops, there it is. This line represents the average of the CO2 emissions. So I would say that some of these, for the smaller x values, we have values that are below the average. And for some of the larger x values, we have values that are more than the average. And it looks to me like there might be a line sort of going through the data, something like this. Okay, so this line represents the average of the y's, the average of the CO2 emissions. And what we want is a line that goes through, goes right through here, through the blue, as best as we can. And by the best fit line, I mean it's going to hit as many of these blue dots as we can. Or even if we don't hit any of these blue dots, we want it to pass as closely to the blue dots as possible. So the blue dots miss our line by the least amount. So to make a line, we might do something like graph a line. Y equals mx plus b. And since I don't know an m and a b, I would have to guess them. And since Desmos does this so nicely, I think what I'll do is make a slider for each. I think I'll make my line blue because it's going through our blue dots. And then I'm just going to play with the slope and the intercept until I get a line, until I get a line that's kind of going through my data. So if I eyeball this, I'm kind of looking like it's coming down like this, coming down like this. It looks to me like the intercept of 0 might be a good place. It looks like maybe it would hit a little higher, like up in here, maybe around 50. But I'm going to start out with an intercept of 0. Okay. And then I'm going to angle this thing up. I'm going to tip this up until it's tipped up with the slope going through the point. So I'm going to need a much bigger M. So one of the things that you might do is make it bigger. Right? And then drag it over here. Still not steep enough. So I'm going to say, okay, let's go up to maybe 1,000. And I'm going to say, whoa, too steep. Okay, that's looking better. And if I want, I can slide this up a little ways. Let's make this go up to about, I don't know, a couple hundred so that I can slide it up and down. Of course, my slope in this case is going to be positive. So I'm going to start at 0, go to 200. And I'm going to say, okay, maybe I can move this up and down a little bit. Okay, so that it sort of passes, right, through the data so that these points miss my line by the least amount. So I take all these differences and I find where the line that has the smallest, we call it least squared error. So maybe it should be, I don't know, should be a little bit steeper. You have to use your eye to kind of figure out, you know, which that is. That one actually hit that point, right? And it is pretty close to these 3. And then it's missing these by a little bit, but it kind of splits the difference between these 2. So I would say that line looks pretty good. That's a line with a slope of 226 and an intercept of 0. And I would say, here's what I would say. I would say that the blue dots miss the blue line, okay, by less than the blue dots miss the red line. And so if I take the distance this point is off the red line, and then the distance this point is off the red line, and then the distance this point is off the red line, some are going to be over and some are going to be under. And by the nature of the mean, if I added them all up, I would get 0, just like we did when we calculated the standard deviation. So maybe what I'll do is I'll square all these distances and talk about the average squared distance from the average. Sounds like the standard deviation, doesn't it? And what I want to do is I want to say, if I use this blue line, the sum of the squares of the errors is smaller than the sum of the squares of the errors for the red line. So my blue line's better. That's what it comes down to. And the standard that I'm going to use is the least squares, the sum of the squares. Okay, how are we doing so far?
I can't get Desmos to work like you're getting it to work.
What part of Desmos is causing your problems?
I don't know. I just can't get it to work the same as you're getting it to work. Like the M equals brought up that line. I'm not seeing any line.
So if you type mx plus b, it doesn't ask you for sliders for m and b? So if I type something,
Hold on.
so if I type like mx plus b, then it's asking me for sliders for m and b. So it automatically makes them for you, or it should.
Well, I'm doing this on my phone too, so it's
Yeah, it's a little small. You might wait until you can get to your computer and try it where you got a little bit bigger screen. That sometimes helps a little bit.
well, I'm at home, but I only have one screen, so I don't want to be like trying to do Zoom and then trying to do
Okay.
that So, and then I can't get a lowercase m after the y. I don't know how to do that on here.
Oh, I don't know either on the phone. I just typed it on the keyboard on the computer. Well, I'll tell you what.
Okay, okay.
Yeah.
I think
Okay.
okay, I got it.
Okay.
Okay, I got y equals ym.
Y equals ym. You want mx plus b to get
Oh, I'm looking at the wrong. Mx plus b. Okay. Okay. And then it says add slider.
Yep.
And then hit M.
Then hit all, I think, because you want one for both. And then you should be able to change this. The slope's going to be, say, between 0 and 1,000, maybe. And the intercept's going to be between 0 and it looks like maybe 200. And so then you can kind of tip the angle, right? Tip the angle and slide the thing up and down until it looks like it's going through the data pretty well.
Yeah, I don't see a line. A line's not showing up on mine.
Okay, well, keep playing with it or just listen for a while and kind of watch me, and then you can go back and look at the recording, or you can have a chance to, just when you have more time to play with it. I think that that you should be able to maybe figure that out, and if not, I can kind of help you individually.
All right.
Okay. All right, so that's where we are so far. Let's try. I want to try another one. Okay, so what we had just looked at was, I gotta get this out of the way. We just looked at this constructing the scatter plot for GDP and CO2. So then you get something similar to this, right? This is the one they got, and that looks a lot like ours in Desmos. So then try again, right? That's kind of the plan. So the next one that we want to do is all of this data, and this is kind of a nice example that the author uses, Larson uses for sort of the rest of the chapter. So this is a good one. Once you type this data in, then you can use it for lots of examples. And this is the duration of Old Faithful's eruptions, right? The geyser, right, in Yellowstone, and the time until the next eruption. So what they're saying is if you have a longer eruption, then it's going to take longer until the next eruption. Kind of basically it sprays out all of its hot water, right? And then it doesn't have any left. So it takes longer to build up more steam. And so the question is, if you time the eruption, then you should be able to predict how long it's going to take before the next eruption. So let's say you have a 1 minute eruption. Well, actually the scores are kind of between about almost 2 and 5. So say you have a 2.5 minute eruption, then how long do you have until the next one, right? Do you have time to go eat lunch? Do you have time to go explore some more of the park? I mean, when should you be back? When should you anticipate the next eruption? And so what we want to do is make a scatter plot, and then we want to see if there's a relationship or not. Now you can see in the class notes that I gave you that it shows you the details of how you would do this on your calculator. I think today I want to just use one piece of technology at a time. So I'm going to keep using Desmos. But if you're on your calculator, you can certainly use the calculator as well. And here's some, in the book, there's some more details of the step-by-step of how you would do that. So for me, I'm just going to move this back over here to the side so I can see it. And I'm going to go back to Desmos. And I'm just going to say, hey, you know what? Start a new blank one. I'm just going to start from scratch. So here I am, everything's cleared, and I'm starting back at the beginning. So what I need to do is I need to say, add a table, and then, you got to put all this data in there. So you can't copy and paste it because it's in a PDF. Sometimes you can copy and paste it, but sometimes you just have to type. And so you're like, well, that's kind of boring. And the answer is, yeah, I guess, but you just have to do it anyway. 1.9, 1.93, 1.98. In this case, they put it in order for you already, which is nice, because then it's easier for you to catch an error if you make one. 2.3, 2.37, 2.82, 3.13, 3.27, 3.65, 3.78. So we've got a lot more data this time. Hang in there and just keep typing. That's 3, sorry. 3.88, 4.1, 4.27, 4.3, 4.47, 4.53, 4.55, 4.6, and 4.63. Okay, then for the Y's, we've got 56, 58, 62, 56, 57, 57, 60, 57, 61, 73, 76, 77, 77, 79, 85, 80, 89, 89, 86, where am I? 89, 89, 86, 89, 86, 92, 91. Uh-oh, huge problem. What's the problem? I'm off by 1. So somewhere the data is wrong. And it's likely that this is going to be the case. Even though this looks really super easy, I would try this a couple of times before I took the test. Because as you can see, you can get off by 1 and you got to go find it. And it takes a little practice to get these in there correctly, especially if you're talking while you're trying to do it. 58, okay, 62, 56, 77, 67, 61, 73, 76, 77, so those look good. 79, 85, 80, 89. Should have been a 90 right in here. So I need a 90. Then I've got two 89s. Then I've got 86, 89. Then I've got 92 and 91. And now I'm down to the bottom. Well, it's good that both lists have the same length, right? But that doesn't mean I typed them correctly. So you're just going to have to be careful in this part. If you get a red X, go back and look at your data, see if you put in your data correctly. So that seems pretty straightforward, but you are going to have to practice a little bit. So then what? Notice that they're green and notice that they're turned on, but I don't see them. That's because my X's are between, say, 2 and 5. I can see 2 and 5. There's the X's between 2 and 5, but my Y's are between, I don't know, what's the small one? It looks like the small one's about 56 and the big one's about 92. So I need 50 to 92. So I can zoom out like this, and there they are way up here. But then my X's and Y's are different sizes. So I like scrolling, I like making my scale on my axes different. So I'm going to say the X's go between 0 minutes and 5 minutes. And I'm going to say the Y's go between, 30 minutes and 100 minutes, maybe something like that. And then I've got sort of all the data. Notice that all the data is way up here, way away from the x-axis. And so sometimes, especially if you're making the graph and you want to see the data, we can sort of zoom in like this on the data, and maybe we can just not see the x-axis because it's way down there. Okay, so if you're making a graph, one of the things that you might want to do is truncate the axis. Remember that if you truncate the axis on a graph, you got to put a lightning bolt through it, right? You got to put a lightning bolt through it. So for us, I might start at 50 and go to 100. If I were doing this on paper, sorry, it keeps scrolling on me. If you're doing it in Desmos and you want to see the data, you can't put a lightning bolt, so you're just going to have to kind of zoom in on it like this. And then I can, you can see in the margins, good grief, it's having trouble with it. You can see along the margin here that it puts in sort of light gray, the X's, right? And the Y values. Okay, I can't quite see, there, now I think I can see all my data. Okay, so now the question is, how do we do? And I'm gonna make it, if I can, I'm gonna try to make it just a little bit smaller. There we go. So then what I would do is I would go back and I would look over here and I would say, wow, look at that. When I did it on my calculator, I got something very similar. Okay, that's called a scatter plot. Questions on making a scatter plot? You can do it by hand or by calculator. I'm going to strongly recommend that we do it by calculator. Now, look at this next ugly thing that's coming up. We want to know how strong is our relationship. And so to figure out how strong our relationship is, we might simply look at the graph. How strong is this? Real strong. Those are right on a line. What about these? These are kind of loosely around a line, and these don't seem to be around a line at all. So we would say strong relationship, some relationship, no relationship. Here we have a line, but the line has a negative slope. So we would say strong with a negative relationship. Here we would say medium, right? Stronger than this, more linear than this, but in a negative direction. And here we would say, nope, they just seem to be scattered all over the place. I would call that no relationship. So the question is, what about our data? So let me get this out of the way. What about ours? So here's ours. Is that positive or negative? And since it seems to be getting, the X's get bigger, the Y's get bigger, we'd call that a positive relationship. And then we would say, what about, what about the strength of it? Does it look like a line? Well, that looks pretty linear to me. And so if I were, you got to just sort of practice with this a little bit on whether you call that strong or medium or weak. I would call that sort of a medium linear relationship. So I wouldn't say that's super strong. I wouldn't say those points are exactly on the line, but I would say they're pretty close. Okay, so I would call that a medium strength positive relationship. But it turns out that there's a way for technology to find the line that fits the best and to tell us or give us a number that measures its strength. Now, it's going to be different on different technology, but I'm going to show you how to do it on Desmos. So down here in a new item, we're going to say y1, and instead of saying equals, we're going to say this twiddle, right? That little tilde or twiddle, it says it's about equal to. In other words, I'm approximating my y's using linear regression. Build a line. What line? We want it to be a line, so we say m, but now instead of just using the x's, we're going to say the x1s plus b. So I'm going to, let's see, to make that, I don't know if you can see it. Let me, what should I do with the data? Here, let's do this. I'm going to add a folder. I'm going to call it the data. Okay, I'm going to put my folder up here at the top, and then I'm going to put my points right inside this folder so that I can close this up so that I have room and you can see what I'm doing. Okay, so you can either scroll up or you can put it in there. I just hid it away inside the folder. So there's the raw data, and then I'm just going to close it up so that I can look at the regression line. So here's what Desmos calculated. And you can follow along in the book and see how your TI-84 also does the calculation. It's going to say, here's a line that goes through this data, okay? And not only is it a line, but instead of just guessing it like we did in the last example, Desmos calculated it as the line of best fit. Okay, and so in this case, our line has a slope of about 12.6 and an intercept of 33.4 or so. And that line is going to go through the data the best. In other words, those green dots are going to miss this line by less than they would any other line that we could draw. Now, check this out right up in here. R equals 0.9797. The R here is going to be the same R that they're going to ask you to calculate here with this big messy thing that nobody actually does anymore because Desmos does it for you. It's called the linear correlation coefficient. And it's going to be a number that indicates how well this data, or how linear this data is, how much this, or how strong the relationship is between the X and the Y. And it's going to be a number between -1 and 1. So if it's negative, that means that the slope is going down. And if it's positive, it's going to go up. 0 is going to say there's no relationship at all. And 1 means that the dots fall exactly on a line. So our R value turned out to be 0.9797. This is a very strong linear relationship. Okay, anything about 0.95 or better means the dots are following the line pretty good. Okay, if you get an R value of, say, 0.8 or less, we would say that there's not much of a relationship between the X's and the Y's. So it's pretty nice. Instead of doing this calculation, which you can certainly do by hand, Desmos does it for you. So does your graphing calculator, Excel, StatCrunch, all those things. Okay, so what do? We find this linear correlation coefficient. It turned out to be in these calculations 0.979 as well. Here's Minitab, Excel, TI-84, StatCrunch. They all will produce it. And what does it suggest? Well, it's a number between 0 and 1, and this one's really close to 1. So we suggest a strong positive correlation, meaning that as X goes up, Y goes up. Okay, so our first deal is just kind of eyeball it, make your own line, guess, okay, and then kind of look at the data and estimate how strong you think it is, and then use technology to actually get a number, right, that measures its strength. And then it tells you, okay, how do you estimate this stuff? And I'm not going to do this stuff today, so I'm going to skip all that. Then we're going to do some, I'm going to skip down to here where it says correlation and causation. I'm going to wrap it up with this. So notice that in our problem right here, we were looking at the length of the eruption, right? How long the eruption was versus how long it takes until the next one. So if you have a really long eruption, it takes a long time until the next one. If you have a really short eruption, then it takes a shorter time until the next one. So it begs the question, is there a cause, or is there just a correlation? So we want to make a distinction between correlation and causation. Correlation just says that as one goes up, the other goes up, or as one goes up, the other goes down, and that one doesn't cause the other. Okay, causation is stronger. It says that the length of time in the eruption would cause there to be a longer time in between. So you might look at some other relationships between other variables. For example, maybe we want to look at IQ and we want to look at grades. So as your IQ goes up, do your grades go up? Most people would probably argue yes. But does high IQ cause good grades? Okay, I don't know. Maybe they do, maybe they don't. There certainly seems to be a relationship there. Okay. And there are several scenarios for you to consider in the book, right? Here's one down here that I'd like you to consider. It's salaries and average attendance per home game in Major League Baseball. Okay, so the variables, if you graph them, then there's a positive correlation. Okay, but the question is, does the team's salary cause a better attendance? Okay, and you might say, well, I don't know if that's true. Just because they're getting paid a lot doesn't mean that people are going to go watch them, right? Certainly if they're paid a lot, it could be that they're good, right? They're good players and that they win a lot. Because good players get paid more and people go watch teams that win. And so we would say, well, the fact that they win, it might be causing people to come watch, right? But we would call that a third variable or lurking variable, something else that's causing people to come to the ballpark. But we would still get a correlation. In other words, as salary went up, attendance would also probably go up. Okay, so I'd like you to read a few of those scenarios in the book and see if you can make sense out of that, of what they mean by the difference between causation and correlation. And then when you come back, if you have questions about it, we can go over a few more of those examples. Okay, basically I was on the share the whole time, so there wasn't too much for me to write down here. I don't do a lot of correlation and regression by hand. Right? You can certainly make graphs by hand, but we just don't do that much anymore. And so I would find whatever your favorite technology is. And here, I mean, as you can tell, I really like Desmos, so I would at least give that a try. I might also, and the next time when you guys come back, what I'll do is I'll take a look at doing correlation using your TI-84, because a lot of you have been using calculators. But find your favorite technology and then figure out how to use it to make a scatter plot. Okay, that should be your task for the rest of the week. I think that gets us most of the way through section 9.1. It certainly is enough so that you should be able to get started on the homework. And then if you have some problems with it, you are certainly welcome to send me an email or even stop by tomorrow. You can stop by office hours and ask me some questions. Okay, that's about it. Do you guys have any questions before we take off?
So on the test, if you want us to show our work, how do we do that? Do you want us to show scatter plots and stuff?
That is a very good, yeah, that's a really good question, Jason. I think that you'll see in the homework in my stat lab the kinds of questions that they do. For the most part, what they do is they'll say, make a scatter plot. Okay, which one of these scatter plots is it? And they'll give you a multiple choice and they'll just present you with 4 different ones. And you can pick the one that makes the most sense. If we were pencil paper in the classroom, then I might have you make a scatter plot actually on paper. But I think when we're working electronically, you know, worst case scenario, make it in Desmos, take a picture of it with your phone, right? You can always do that and turn it in. But I think that most of the time what you're gonna see are, they're gonna give you some scatter plots to choose from, and it's gonna be sort of a multiple choice type question.
All right.
Okay.
And do we need a camera for the exam?
No, you know, I've thought about that quite a bit. I need to be able to proctor the test some way. So if you if you're working on your computer and you have a camera on your computer, then I'd like to see your face when you get started. But I know that like John and Jasmine have been calling in on the phone. I don't know if that's because you don't have access to a camera. I don't want you to have to run out and buy a camera for this. What I'm going to do is I'm just going to open the test during that window, 8 to noon. but I'd like you to check in with me. So at a minimum, you know, do what you did now, you know, call in and, you know, be on the phone with me. That's okay. And say, hey, I'm here. I'm ready to take my test. I'll be able to see that you're working, right? Because I can see that you're working in Canvas. And then I think that that'll be good for proctoring. I don't want you to have to go out and buy anything new just to be able to take the test.
All right. Yeah, I'm doing this on my desktop, but it doesn't support the audio for some reason. So I have to call in for the audio on my phone.
Okay.
And then,
Yeah.
but my desktop's kind of old, so.
Well, do the best you can with the technology that you have. I think all of you that are here today, the way that you're logged in is going to work out just fine. Okay, so what I would ask for those of you that have cameras like Adassa and Melim, I'd ask that when you first log into me, you know, turn your video on, wave good morning, and then you can mute your video and your audio, and then just go about taking your test. That would be perfectly okay.
All right.
Okay.
Cool.
Other questions?
So when you're taking the exam, say if you're taking it like obviously online because
Yep.
it's the mode, if you call in through Zoom that way, will it still let you open a different window and like take the test that way?
Yep, it should. You can just open
Okay.
Zoom in a separate window. Yeah. So
Okay.
are you on, Jasmine, are you on Zoom or just on your phone?
I'm on my phone, but I believe I can do it on my laptop.
Okay. Like I said, you don't need to go buy anything new, okay? But I would like for you to check in. So if you can't make it work with your video or you can't make it work on your laptop, you can just call in like you did today on your phone, check in with me, and then take the test in Canvas.
Okay.
Okay?
All right.
Okay, you guys, well, that is it. This is Thursday. We only have 1 week left, if you can believe it. So maybe get started on chapter 9, you know, over the weekend, and then we're going to do the last 2 sections next week. If you have problems, you know, you can write me an email and I'll get back to you as quickly as I can. Otherwise, have a great weekend, and we're going to see you on the last week of the semester, okay, on Tuesday.
All right.
Okay, see you
Thank
guys.
Yeah.